Okay, let's solve another sample problem. For this given problem, we are required to compute the maximum bending stress or the maximum flexural stress for the beam shown below. So we have here a simply supported beam loaded with triangular load and rectangular load. And then also given in this problem, the cross-sectional area of the beam, which is rectangular in shape. Okay, so the unknown parameter is bending stress. FB is equivalent to MC over I. But then, it is asking for the maximum bending stress. For us to get the maximum bending stress, we will use the maximum moment that we will get in this beam loaded. And that is multiplied by the centroid over the moment of inertia. Okay. So, isa-isa natin kukunin yung mga parameters na to para makuha natin mismo yung unknown parameter, which is maximum bending stress. First one, kunin muna natin yung maximum moment. Para makuha natin yung maximum moment, drawing natin yung shear and moment diagram. And then, para makuha yun, compute first for the reactions at the support. Okay, so assume natin this is the reaction at point A, and then this is our reaction at point C. So if we will get the value of the reaction at point A, we'll just take summation of moment at point C, taking clockwise direction moment will be positive. So yung RA natin papunta kay point C, ang galaw ay clockwise direction, so that is positive. That is RA multiplied by its perpendicular distance. Ang perpendicular distance niya ay a total of 6 meters. Yung 30 kN na rectangular load, pababa po siya. Papunta kay point C, yung galaw niya ay counterclockwise. So that is a negative moment. So, para makuha natin mismo yung kanyang moment, gagawin natin mismo itong rectangular load na to na concentrated load. Yung concentrated load na yun or point load mag-a-act sa centroid ng rectangular area na yan. Nasaan yung centroid? So, assume natin ito yun. So, nasa mismo yung centroid niya, kalahati mismo ng base, kalahati ng 3, 1.5 meters. Ano na ang value ng ating concentrated load na yun? That is just the area of our rectangular load. So, since rectangle, base times height tayo doon. Ano bang base? 3. Ano ang height? 30. So, 3 times 30, that is 90 kilonewtons. So, imbes na yung ating rectangular load, yung ating consider, i-consider na lang natin yung point load na to, pag nag-moment. Okay, analyze natin yung moment niya. So, that is 90 kilonewton multiplied by perpendicular distance from this point to this point. 6 meters yun, 1.5 to 4.5 meters na lang yung kanyang perpendicular distance. Next one, meron tayong triangular load dito. Again, ganun din gagawin natin. Same kay rectangular load. Kaya lang, yung triangle mismo natin, dapat alam nyo din yung ating centroid nun. So, assume natin yan yung ating concentrated load or equivalent concentrated load ng ating triangular load. Ano mismo yung kanyang value dito? Yung magnitude ng ating concentrated load. It is just the area of our triangular load. Ano ba yung area? 1/2 base times height. 1/2, ano ba yung base ng triangle? 3. Ano yung height? 30. So, 1/2 times 3 times 30, that is 45 kilonewtons. At mag-a-act po yun sa centroid ng triangle. Nasaan po yung centroid ng triangle? Yung centroid po niya, from this point, papunta sa pinakamaliit na part ng ating triangle, that is 2/3 of the base. Pero kapag yung centroid papunta sa pinakamalaking part ng ating triangle, that is 1/3 of the base. So, consider natin yung papunta sa pinakamaliit na part ng triangle, which is 2/3 of the base. 2/3 ng base 3, 2/3 of 3 is 2 meters. So, yung moment nun, that is minus, dahil yung galaw, counterclockwise, 45 times perpendicular distance of 2 meters. equivalent to 0. So, solving for the reaction at point A, it will give us a value of 90, this is 360, 405, and then plus 90, 495 divided by 6, that is 82.5 kilonewtons times 6. Okay, so tama. And then, we will take summation of forces along vertical axis equivalent to 0, taking upward, forces are positive, para makuha natin yung reaction at point C. Or, pwede tayong mag-summation of moment at point A para makuha din yun. Check nyo na lang to. So, ito, gagawin ko para mas madali na lang mismo yung solution. Ito na mismo yung gagawin ko. So, ano yung mga upward forces natin? Reaction at point A, 82.5 plus RC minus 90 kilonewtons minus 45 kilonewtons equivalent to 0. So, madali na lang yan, guys. Reaction at point C will be equivalent to 52.5 kilonewtons. So, we already have the reactions. Pag meron tayong reactions, pwede na nating ma-drawing yung ating shear and moment diagram. So, para mas madalian tayo sa shear and moment diagram, ang gagawin po natin ay area method. Okay. First one, yung shear diagram muna natin. Okay. Let's assume that is our shear diagram. Meron tayong pataas starting from 0. Meron tayong pataas, reaction at point A. Tataas ng reaction at point A, which is 82.5 kilonewtons. And then, 82.5 kilonewtons starting from 0, tataas 82.5. 82.5. So, start tayo kay 82.5 minus. Bakit minus? Dahil pababa yung area ng ating load. Minus the area. Ano yung area? 90. So, minus 90 dito, that will be negative 7.5 kilonewtons. So, nakay 7.5 na daw tayo. Negative 7.5. So, paano natin i-connect yung dalawang point? 0 degree yun. Dito magiging first degree. Anong first degree? Parang triangular in shape lang. Okay, next one. Negative 7.5 minus ulit. Minus, bakit minus? Pababa ulit yung area ng, or yung loading, o yung direction ng ating area of triangular load. So, minus the area. Anong area ng triangular load natin? 45 kilonewtons. So, that is negative 52.5 kilonewtons. So, bababa pa. Negative 52.5. Eto, first degree. So, dito, magiging second degree curve. So, paano yung second degree curve natin? Hindi natin alam kung paganyan, sad curve, or happy curve. Tingnan natin, analyze natin. Yung curve natin nag-start from 30. And then, maglalas kay 0. So, nag-start siya sa mas malaking part. Ibig sabihin, ang tawag natin dito ay maximum curve. Paano po ba tayo makakabuo ng maximum curve dito? Pag sad curve, medyo malit yung curve natin. Pero kapag happy curve, ganyan, that will be a maximum curve. Mas maumbok, kumbaga. Okay, that is second degree curve. And that will be our shear diagram. Okay, next one. Yung moment diagram naman natin. So, extend lang natin to. Okay, anong napapansin nyo guys sa ating shear diagram? Na-intersect niya mismo yung horizontal axis natin. Anong indication ng mga intersection po natin? Ang indication po natin doon ay, yung mga intersection na yun, nandun po mismo yung mga maximum moment natin. So, para makuha natin yung maximum moment, ipro-project natin mismo yung intersection na yun. Okay, project natin. And then, para makuha natin mismo, kailangan natin mismo yung position ng intersection na yun. So, para makuha, let this be x. Ano napapansin nyo guys para makuha natin? Anong gagawin or anong method? we will use ratio and proportion dahil yung triangle dito ay similar sa triangle dito. So, if this is x, ito ay total of 3, ibig sabihin, ito ay 3 minus x dahil total yun na 3. So, by similar triangles po, that is, height na 82.5 corresponds sa height na 7.5. Take note guys, negative yun, pero positive yung ginamit ko dito. Bakit po? When dealing with ratio and proportion, we are dealing with distances. At pag sinabing distance, yun ay scalar quantity, magnitude lang po, ibig sabihin walang direction, hindi natin i-consider yung sign kapag nagre-ratio and proportion. And that will be equivalent to the base. X corresponds to the base of another triangle, 3 minus x. And then, solving for that, we will get a value of x which is equivalent to 2.75 meters. Okay, since nakuha na natin yon, po pwede na natin kunin yung mga areas dyan. And then, makukuha natin yung 3 minus x, that is 0.25 meters. 3 minus 2.75. Okay, let's do the area method. Starting with 0. So, 0 plus, bakit plus po? Nasa taas yung area ng triangle na to. So, 0 plus 1/2, the base is x. Ano yung x po? 2.75 times the height, 82.5. So, do the math guys. That will be equivalent to 113.4375 kilonewton meter. So, positive, nasa taas. O, paano natin i-connect yung dalawa? Nag-start tayo kay maximum. Sabihin maximum curve. Paano tayo makakakuha ng maximum curve? Pag ganyan, mas maumbok po dapat. Tama, dahil pag ganun po yung curve natin, kukunti yung curve natin, hindi siya maximum. Okay, next one. Starting with 113.4375 plus. Plus, i-plus naman natin yung area ng triangle dito. So, that is 1/2 the base. Yung base niya ay 3 minus x. Yun ay 0.25. Ang height niya po ay negative 7.5. Po, pwede na kayo mag-minus doon. Kung gusto nyo, since alam naman natin negative yung area. Pero, huwag nyo i-consider na yung sign dito. Okay, take note of that guys. And that will be equivalent to 112.5 kilonewton meter. So, bababa lang siya ng konti. 112.5. So, paano natin i-connect yung dalawang point? Papansin nyo, yung curve natin nag-start from 0, papunta sa 7.5. Nag-start siya sa minimum. So, dapat minimum curve yung makukuha natin dito. Paano natin makukuha yung minimum curve with respect to the axis of the first point? Yan po, facade curve. Ito yung minimum curve na tinatawag. Dahil nag-base po tayo sa axis of the first point. Hindi dito sa ating horizontal axis na yan. Huwag kayo malilito po doon. And then, starting from 112.5 minus yung area naman ng graph na to. So, paano yung area na yan? Papasin nyo, dalawa yung area na yan. Hati natin sa dalawa. Area ng rectangle. Anong area ng rectangle na yon? Base times height. Ano yung base? 3. Ano yung height? 7.5. Papansin nyo, minus na yung ginawa ko doon. Dito, positive na. Dahil alam ko naman na negative yung area doon. Minus. Area ng second degree curve. Ano ba yung area ng second degree curve? Parabola yan. Parabolic curve. So, anong area ng parabolic curve? That is 2/3 base times height. Pero kapag hindi siya masyadong maumbok, 1/3 base times height yon. Take note of that, guys. Alam nyo na mismo yun sa geometry natin. So, that is 2/3 base of 3, a height of. So, eto, dito na lang. From this point to this point, 52.5. Eto lang yung height niya. Ma-minus natin yung 7.5 dito. So, that is 52.5 minus 7.5. Dapat yan ay magiging 0. Pag hindi po siya naging 0 po, ibig sabihin, hindi po tama yung mga values na nakukuha natin. Yun po yung checking nyo guys. Dapat po palaging nag-0. Okay. Yun na natin. Paano natin i-connect? Second degree curve, third degree curve. So, nag-start siya dito sa 7.5. Mas mataas yung 52.5. Ibig sabihin ito ay minimum curve. So, dapat minimum yung curve na makukuha natin dito. Starting from the axis of the first point, dapat pa ganyan po yung ating curve. Dahil ito yung tinatawag na minimum curve. And that will be our shear and moment diagram. And we can see that from our moment diagram, we can get that the maximum moment is equivalent to 113.4375 kilonewton meter. Okay, tuloy po natin. So, na-compute na po natin yung maximum moment natin. So, yung problema na lang po natin ay yung centroid natin tsaka moment of inertia. First one, yung centroid po natin. Centroid ng cross-section natin, madali lang naman i-analyze. Alam naman natin, for rectangular section, kalahati lang mismo, that is 0.5 meters divided by 2. So, centroid is 0.25 meters. Ito yung neutral axis natin. Pataas or pababa. Bakit pataas or pababa? Dahil dito sa outer fiber sa taas tsaka outer fiber dito sa baba, nandun po yung ating pwesto ng ating maximum flexural stress. Nandito po yung tension part, nandito po yung compression part. So, for the moment of inertia, meron na tayong derived formula for that. For rectangular section, that is BH cube over 12. Substitute lang natin. The base, anong base ng ating section? 0.3 meters. Anong height niya? 0.5 meters raised to 3 divided by 12. So, what is I? 0.003125 meter raised to 4. Okay, so na-compute na natin lahat. We can now compute for the maximum flexural or bending stress. Substitute lang natin. Maximum moment. 113.4375 kilonewton meter. Centroid natin, that is 0.25 meters over moment of inertia, 0.003125 meter raised to 4. So that will give us a value of 9,075 kilopascal. And that will be our maximum flexural stress. Okay, dagdag lang po natin for this given problem. We can compute also for the value of the maximum shearing stress for the beam section given. And we know for a fact that shearing stress FV is equivalent to VQ over IB. That is our formula. But for a rectangular section, meron tayong derived formula for that, for the value of shearing stress. And that is FV 3V over 2A. Take note po, ito ay nagagamit lang po kapag rectangular section po tayo. Since it is asking for the maximum parameter, FV maximum is equivalent to 3V maximum over 2A. So, nakuha naman na natin mismo yung shearing diagram natin or shear diagram natin, makukuha na natin yung maximum shear stress or shear load natin. And for this graph, mapapansin naman po natin na yung pinaka-maximum ay yung 82.5 kilonewtons. So, yun yung ating substitute. So, that is 3 times 82.5 kilonewtons over 2 times A, the cross-sectional area of the beam, 0.3 meters times 0.5 meters. So, calculator lang natin yan. And that will give a value of 825 kilopascal. And that will be our maximum shearing stress.